Chapter 9, Center of Gravity and Centroid. All right, class. Today, we're going to talk about something very important that helps engineers make sure big things like buildings, bridges, ships, and even playground rides don't tip over or fall. This is about the center of gravity and the centroid. Imagine you're carrying a tray of food. If you balance it exactly in the middle, it stays level. But if everything is pushed to one side, it tilts and you might spill the food. That balance point is like the center of gravity, where all the weight is nicely balanced. Now, every object is made up of tiny little particles, each with a tiny bit of weight. When we want to know where to balance the whole object, we have to think about where these tiny weights all come together at a single point. That's called the center of gravity. If we think about how much stuff there is in the body without worrying about weight, we call it the center of mass. And if we just care about the shape of the object, like a piece of paper or a wooden board, we call it the centroid. When we look for the center of gravity or centroid, we can imagine chopping the object into little pieces and adding up all their locations using simple math rules called moment balancing. It's like finding out where all your friends should stand on a seesaw so it stays level. If the shape is simple, like a square or circle, the centroid is right in the middle. But if the shape is uneven or has holes, we have to do a little bit of math or sometimes use tricks like symmetry to find it. Engineers use something called Pappus and Guldinus theorems, which are clever ways to calculate areas and volumes when shapes are spun around. Imagine spinning a curved stick around and making a circle, or spinning a flat shape like a fan blade into a bowl shape. These theorems help us quickly figure out how much area or space is created, which helps in making things like tanks or domes. When shapes are made by combining simple pieces, like building blocks, we use something called composite bodies. We find the center of each little piece, and then we add up all their effects like a team working together. If there's a hole, we treat it like a negative weight, like a missing piece in a puzzle. Throughout the chapter, we also learn simple step-by-step ways to solve problems. First, we divide the object into simple parts. Second, we write down where each part's center is. Third, we count how much each part weighs or how big it is. And finally, we calculate the final center point. By doing this, we make sure everything we build stays balanced, doesn't topple over, and works safely, just like you carefully balance your school bag on your bicycle without falling.